Let's start this case. Consider a simple harmonic motion of time period capital T. Calculate the time taken for the displacement to change value from half of the amplitude to amplitude. In this particular problem, time period is given to you as T, which can be written as 2 pi by omega. So for this particular counterpart, omega can be written as 2 pi by time period capital T. Now if we consider this particular case, now he wishes that the displacement changes from half the displacement changes from half the amplitude to the complete amplitude. So basically the particle should move from x is equal to a by 2 to x is equal to a. Now this problem can be done very easily if we know the concepts of comparison of circular motion with SHM. Now how do we compare circular motion with SHM? Let's draw the circle and mark down the points which we intend to have over here. See, basically the particle initially should be at x is equal to a by 2, so this separation should be, or this distance should be equal to a by 2 initially, and the phasor representing the particle should be over here. It should reach x is equal to a, which is this particular point, since this point is x is equal to 0. So basically the particle has to move from the initial point which is marked down over here to final point over here by this particular way. And if we see the circular motion, the particle's phasor has to rotate by this particular angle, let's call it theta, to come to this particular point. Now if let's consider this to be O, let's consider this to be P and this to be Q. If we draw triangle OPQ, the triangle OPQ is something like this. This is point O, this is point P, and this is point Q, where OQ being the radius of the circle would be equal to the amplitude A, and OP is equal to a by 2 as mentioned in the problem. Let's call this angle to be theta. Now if we call this angle to be theta, in this particular scenario, cos theta can be stated as how much? A by 2 divided by A, or 1 by 2. So theta can be stated as how much? That can be stated as pi by 6, or theta can be stated as pi by 3 or 60 degrees. Now basically if we wish the particle to travel from half of its initial displacement to its complete half of its amplitude to its complete amplitude, basically it has to go from I to F, and it should have covered up an angle of theta is equal to pi by 3. Now the particle moves on the circular motion within omega. Angular velocity is equal to omega, which as above calculated is 2 pi by time period t. So the time taken would be equal to angle traversed by angular speed, or pi by 3 into 2 pi by time period t, which comes out to be time period by 6 in this particular problem, and that is the final answer to this particular problem.